So we were just talking about the umbra and the penumbra and the shadows that they cause on the moon during a lunar eclipse. And now let's do a timeline so that you see how this all works. Again, we're talking about a counterclockwise motion of the moon that is revolving around the sun. So we're starting here at this lower level when we're talking about an eclipse. And you should know that all lunar eclipses start out as penumbral eclipses. They start out moving into the penumbrum, then moving into the umbra, then moving back into the penumbrum up at the other side, and then back out of the penumbrum. So all lunar eclipses start in this way. But in this way, you are moving into the light shade of the sun, where some sun rays can get to the moon, but not all the sun's rays can get to the moon. So this is a lightly shaded area. It's known as a penumbral eclipse. And in fact, here's an example of one in a time-lapse photograph. You may never really notice when a penumbral eclipse goes by because the penumbral lunar eclipses are quite faint and they are just shadows over the moon. So you may think it's just haze, or you may think it's a light stratus cloud that's going by the moon. But if you know that an eclipse is going to happen, you might look for that. In addition, I've got here as well for you. Yes, right here. We are going to have a penumbral lunar eclipse during our semester, which is really excellent news if you want to head out there at 2:32 in the morning until about 7 a.m. in the morning and watch for the shadow to go over the moon. It won't be spectacular. This is a penumbral eclipse, so it's just a partial shadow. It will not be spectacular, but you should know that on November 30th, 2020, right over our area in New Jersey, yes, there will be a penumbral eclipse. Later on in this chapter, we're going to talk about what these directions mean for that. So let's go back for a second and talk about the second type of lunar eclipse. About 65% of lunar eclipses move from penumbral into a partial lunar eclipse. And the difference is this. In the partial lunar eclipses, the angles line up so that the sun, the earth, and the moon are a bit more angled, and the moon actually moves into the earth's umbra, which is the full shadow. And so these are the eclipses where you see a bite eaten out of the moon on a partial lunar eclipse. In these eclipses, part of the moon will be in the penumbra and part of it will be in the umbra. So you'll see a bite taken out and a shadow. In looking at partial lunar eclipses, this is a partial lunar eclipse here. And 65% of all the penumbral lunar eclipses will go on to become a partial lunar eclipse. Consider that we're talking about a counterclockwise rotation of the moon. So we're starting here and working counterclockwise, and over in this area, you would have started with the penumbral eclipse. And then this eclipse graduated into a partial eclipse. Look, you can see the umbra taking a piece out of the moon here. More umbra, less penumbra, more umbra, and even more umbra. This has so much umbra taken out of the moon that you're starting to see the effects of the only light hitting the moon from the refraction of the Earth's atmosphere. Remember red sky at night? Well, that's what we're looking at here. The refraction off the Earth's atmosphere is red, and you're seeing that on this very deep partial lunar eclipse where the umbra comes way down into the moon. And this is not a total lunar eclipse, but it's pretty close to it. And then we're coming out the other side. We are finding less umbra, a little bit more penumbra, and over here to the least amount of umbra, and moving on to the end of the eclipse, which ends with another penumbral eclipse. Now let's get to the most spectacular version of this, the total lunar eclipses, and about 35% of all lunar eclipses become total lunar eclipses, where the moon moves from outside to penumbrum to partial lunar eclipse to total lunar eclipse, completely in the umbra. No sunlight here can reach the moon, and the earth totally shades the moon. The only light on the moon is refracted off of the Earth's atmosphere. This will move in a counterclockwise direction through this area, and then it will move through the penumbra again and then off again. But let's see a little bit more about how this looks. I don't love this slide, but it is the one in your book, so I want you to be able to reference it. Again, we're talking about the motion of the moon in a counterclockwise direction, and this is a penumbral eclipse, a partial eclipse, a total lunar eclipse, a partial lunar eclipse, and penumbral lunar eclipse. I don't love the pink on the penumbral. I don't think you'll see that very often. But what I did want to point out to you here is that here is the sunlight scattered from the Earth's atmosphere that is imparting the glow onto the totality section of the solar eclipse. And to get back to a slide that you saw in the last segment, again, the sun, the earth, and the moon, and here you see the Earth's ecliptic. Remember, ecliptic meaning that when these angles line up, there's an eclipse. An ecliptic is the Earth's orbital path around the sun. When it lines up with the moon's path around the Earth, you tend to note these eclipses. Let's talk about the timeline on this counterclockwise rotation around here. So here, the moon enters the penumbra that is out here at 2:36 Universal Time, and this area is where the moon enters the umbra about an hour later. These lunar eclipses take place over hours. The reason why they take place over hours is because the Earth is relatively huge compared to the moon, so the moon has a long space to go to get out of the Earth's shadow. So these eclipses take hours. When the moon finally gets into the umbra completely, it's about 2 hours after the start. Then it moves back into the penumbral area and moves completely into the penumbral area, so that this is now starting into, this was a partial eclipse, this is more of a partial eclipse, and here we've got a penumbral eclipse on the other side. Look at the time frame, we're talking about 5 hours. So you can imagine that these were scary events that people wondered if they would ever end, but now they're just photographers' delights because you have so much time to work. We'll see on the other side for solar eclipses.